Hello! GitLab and TriggerMesh have been hard at work making GitLab Serverless happen. So I would like to give you a quick demo of how this looks so far, and keeping in mind that we're in a very iterative process. So this is just the beginning. I'm in one of my repo, gitlab.com/sebgoa/kdemo, and you'll see later I'm going to explain what you'll find in this repository, in this project, but there are roughly 3 functions, one of them being more of an application, but we'll talk about this. There is a serverless.yaml manifest, and there is a GitLab CI. So that's what we have in this repo, and I'll explain further how this is going to work. GitLab Serverless deploys functions inside a Kubernetes cluster, and it leverages Knative. So the first thing that you need to do is to actually create a Kubernetes cluster. You can click on the icon here, Add Kubernetes Cluster, or you can also find it in Operations, Kubernetes. So we're going to do this, and I'm going to click on Add Kubernetes Cluster. You can bring your own Kubernetes cluster, or if you're using the Google Cloud Platform and you're using GKE, you can simply use GKE. So I'm going to create a cluster called kdemo. It's going to use my personal Google Cloud account, run seb, US Central 1, RBAC enable cluster, great, and let's create. All right. So we now have the page that describes this Kubernetes cluster within GitLab. And if I go to my other window here, which is open on the GCP console in the GKE view, I'm going to see that I have a kdemo cluster being provisioned in US Central 1A. Let me zoom in a little bit so that you can read a little bit better. All right, so this provisioning has now started, and once it's ready, we'll be able to start configuring this Kubernetes cluster with Knative and then deploy functions. Here you go. We're now 3 minutes later. Thanks to a little bit of video editing, we see that the top banner on my Kubernetes cluster has changed, and right now it changed even more. If I go back to the GKE console, I see that my kdemo cluster has been provisioned. On average, it takes 5 minutes for a GKE cluster to be provisioned. Here we got it down in 3 minutes and then saved the time thanks to a little bit of video cutting. Okay. To install application in that cluster, we use Helm, the Kubernetes package manager, one of the solutions to install application in Kubernetes. So we're going to install Helm in this cluster. This technique could change. We'll see, but right now that's how we install application on Kubernetes within GitLab. So the Helm installation is taking place. Here you go. We're done. And if I scroll a little bit further down, you see that I could install Jupyter Hub and Prometheus, but there is also an installation for Knative, right? So what I want to do is install Knative because our functions are going to be deployed as Knative objects. So let's click install. You can specify your Knative domain name so that functions will get exposed in a given DNS name. So for me, I'm going to use GitLab TriggerMesh.io, wildcard DNS domain, and I'm going to do the installation. All right. This will take a few minutes. And once it's done, the interface will return an IP address that I'm going to use to configure the wildcard DNS entry for gitlab.triggermesh.io domain. Here we see that the IP address is being assigned. This is under the hood the IP address of the load balancer that sends traffic to a Knative ingress gateway. Here you go, we got the IP address. So I'm going to copy this IP address and I'm going to go configure my DNS domain so that the wildcard address gitlab.triggermesh.io points to this IP address. And thanks to video editing, I'll be back shortly. I've done my DNS edits, so now let's head back to the project and have a look at those files a little bit more. Just to showcase the versatility of the integration, what we have here is actually 3 functions. And one of them is more of an application than really a function. So some of you may get confused, but it just shows the versatility. So this application is defined in the root of the repo. It is a Go application that just returns an HTML page with the environmental variable simple message, right? So if you don't specify an environmental variable, it returns simple message variable not defined. If you do define it, then that's what it's going to return. And that app was taken by Mark Chmarny, the Google Dev Advocate. This app is built with a Docker file. So you do have to write a Docker file for this one. Okay, so it's not fully a function where you just let the system do everything. And the other 2 functions are echo function, where you need to post some payload and it will return what you posted, and hello, which is a Python function which is just returning the time. All right. The echo function is in Node.js, the hello function is in Python, and then the full application is in Go. So we have 3 languages, and we have one which is a full application, but notice that the echo and hello functions, they do not have a Docker file, right? So the GitLab Serverless integration is actually going to know how to build those functions. How does it know how to build those functions if there is no Docker file? Well, you specify them in the serverless.yaml manifest. This serverless.yaml manifest is understood by the TriggerMesh client, and it will create Knative objects that are going to do the build of those functions and then serve them. So you see here 2 functions, the hello and then the echo. You see 2 so-called runtime, which are actually build templates in Knative terminology. So those runtime tells us how we can actually inject those functions inside a container under the hood. So 2 different runtime, one for Node.js, one for Python. The one for Python comes from the TriggerMesh Knative Lambda runtime. So that function is actually compatible with AWS Lambda. Specify a few build arguments. All right. There's one thing here at the top in the provider definition, which is a secret, so that once the images are being built in the Knative cluster, they can be pushed to the GitLab registry, right? So a build is happening in the Knative cluster on GKE, being pushed back to the GitLab registry. But for the full application with the Docker file here, the build is actually happening directly in the GitLab CI, and the image will be also pushed in the GitLab registry. I told you, lots of versatility. Here the registry, well, to make sure that you know that I'm not cheating, I'm going to remove this image. So there are currently no images in this registry for this project. All right? Perfect. So 3 functions. Now, how do we deploy these functions in the Kubernetes cluster that we deployed? We use the GitLab CI. First stage, sample app, that's how we build the applications that has a Docker file. For this, we use the Kaniko project. It takes the Docker file, builds that image, and pushes it to the GitLab registry. All right, that's the first stage. Second stage, we deploy the functions. We use the TriggerMesh client, TM. First 2 steps that we do here is that we set a GitLab registry credentials, one to be able to push, one to be able to pull because of the time to live of the CI tokens. The third command deploys the application, the sample app, our Go applications. It deploys a service called sample app using the image that's stored in the GitLab registry. And the 4th step, which is TM deploy here, this step is going to read the serverless.yaml and it will deploy the functions. It will do the build within the cluster, totally serverless. You don't know how the build is happening, but it will push the function resulting containers to the GitLab registry. All right. So to kickstart this, we can just go to pipeline, and we can just say run pipeline. Create for master. Okay, fine. Create pipeline. Okay. First stage has kickstarted. It will build the image, and then we can check that the image gets in the GitLab registry, and then it will get to the second stage. Here you go. The first stage, building the Go application, has finished. So we see that the Kaniko build has run, and then it has pushed the image to the registry. If I go to the registry in the GitLab interface, I'll see now that we have the sample app image in our registry. Okay, so first stage of the CI has worked, build. Perfect. So far, not so exciting. We know how to do this, except that it was a build using Kaniko, no Docker in Docker. Second stage, more interesting, that deploys the functions. We see the TriggerMesh client in action, sets a push secret so that the builds running in the Knative cluster can push the image back to the GitLab registry, sets a pull secret, then deploys the applications that is based on in Go, the sample app. So you see here deploy service sample app, and you see the variable CI registry image sample app. So this is deploying the Go application based on a Docker image. In itself, it's not extremely interesting, except that Knative gives you scale to 0, so that if nobody is hitting this application, it will scale down to 0. More interesting, the last step, which is the TM deploy, which deploys the other two applications, the echo and the demo. And we see that at the end, we get the URLs. Perfect. Our pipeline has succeeded. Those two stages have succeeded. The build and the deploy, we are all green. Now we can go to the serverless page. Once you go to the serverless tab, you now see your three functions. We see our sample app, our Go application that's been Dockerized with Kaniko and stored in the GitLab registry. And we see our echo function in Node.js and our hello function written in Python with the Knative Lambda runtime. We have three URLs so that we can call those functions over HTTP. Because we configured the DNS domain when we configured Knative. So now if I hit this link, I should get the Hello GitLab from the sample Go application. When I come back and I hit the Hello application, I get the Hello. Current time is 16:36. And the last one, I can just copy the URL for that one, and it's a Echo application. So you'll see that I've tested it before, but you paste the URL here, you give it a body, for example, rocks, GitLab rocks a lot, and then the header application JSON, we send this, and rocks a lot. And if we change this, and we say TriggerMesh rocks a lot, and we hit TriggerMesh rocks a lot. Okay, perfect. What is very interesting is that after a while, the applications will scale down to 0. So the next time you hit the URL, it will take a little bit of time for the functions to actually start. This is the so-called cold start. All right. So this is the beginning of GitLab Serverless, the partnership between GitLab and TriggerMesh, which lets you write applications directly in your GitLab project, and you can define them in a serverless.yaml manifest, relatively simple, and then you can deploy those functions to your Kubernetes cluster using GitLab CI with some steps that use the TriggerMesh client TM deploy service. Hope you enjoyed it. Thank you very much.